Okay, this is problem number 16, page 133, chapter 4, forces in Newton's law. On this particular problem, we're given a 1.5 kilogram object moving along the positive y-axis. Okay, on this problem here, I've drawn a velocity vector going straight up there, and the big deal here is constant velocity. I really don't care about its magnitude. All I know is if this velocity is not going to change, which is what part A is asking, does it keep moving along the y-axis? Well, if it's going to do that, that means its motion is not changing. The only way its motion cannot change is if all these force vectors are in equilibrium. What does that mean mathematically? We need to take vector 1, 2, 3, and 4, break them up into components, and add the components. And we need to see if this is true or not. Do all the x components equal 0? Do all the y components 0? If this is true, then yes, it's going to keep moving along the y-axis. Sum of all forces equals to 0. Therefore, I am not going to have a change in motion. What if one of these pieces here is not 0? Then I need to add a fifth vector to these four that will make it 0. So I need to really go F1 plus F2 plus F3 plus F4. And now that they're asking me, what does F5 need to be? So we've already done a problem like this. It's an equilibrium problem. All right, so we're going to break each vectors into components. Notice I put the sign of each one of the components here. Here's a first quadrant vector. Here's a third quadrant vector, etc., etc. Use your sine and cosine functions appropriately and sum up all the pieces here and here. This is going to be our resultant. Now, if this piece and this piece are 0, then it's in equilibrium. Its motion is not going to change. Now, if these pieces are not equal to 0, then I need to find the equilibrant, which is going to be force vector F5. So I'm just going to take this. I'm going to keep its magnitude, but change its sign. I'm going to keep this y component. I'm going to keep its magnitude, change its sign. And this is actually force vector number 5. This is our answer. However, we're going to have to take our answer from component format, convert it to vector notation using Pythagorean theorem to find the magnitude, in the arctan to find the angle. Okay, just be very careful with your signs, your positives and your negatives, and you should be able to answer this problem without too much trouble.